So the title of this session is Partnering with Machines. I was just talking to some other folks in here about digital transformation. I've been on this nice little semi-whirlwind tour for the last couple of weeks. I was in Buenos Aires, Argentina, Medellin, Colombia, Florence, Italy, and now I'm here in this exotic location with you guys. By the way, if you haven't been to Medellin, who's been to Medellin? I went there a tourist. I came back an ambassador. Go. It's really nice place. We don't want to talk about that now, but really interesting place for innovation, new ideas around urban planning and that kind of thing. There, it still has that Pablo Escobar kind of ambiance to it, but they're getting past that pretty quickly. It's no longer the murder capital of the world, and very innovative and interesting. But digital transformation is one of the things we're going to talk about. Normally, when I was doing these talks, I was talking about humans partnering with machine intelligence. And I dropped that intelligence part off, mostly after talking to Sam Adams over here from previously of IBM, now at RTI, because I know you guys are all really smart. And I don't want to talk too much about, creating real artificial intelligence with the things that we're building. I want to talk about something a lot more pragmatic. First of all, when you guys see partnering with machines, how many of you know exactly what to get out of this session? You have very clear expectations? Awesome. All right, well, let's start with our first algorithm. The first algorithm is satisfaction is results minus expectations. So I guarantee you'll be satisfied from this, since you have none. I do want you to walk out of here with something very pragmatic. I don't know what you wanted to get out of this session or the very rich 2 days that you're spending here, but I want to get really down to the nitty-gritty about things that you can implement using machine learning, because that's my specialty now, although you'll see that I have several, that you can implement, let's say, and then end of October? So not by the end of the year, but let's say by the end of the first quarter, that could, let's say, cost $100K or right around there, that have a 10x ROI. Who's interested in that? What if I said that at 10x ROI would be an annuity? You would get every year forever, right? What if I said you could implement something pretty easy that will give you 600x, 1600? These are all real numbers from projects we're going to talk about that have been implemented in the last couple of years. This isn't, at my last job at Lockheed Martin, I'll just move ahead to let you see my perspective, because I think perspective is important. That's my perspective. That's my entire 30-year career on one slide. I could fit it all in there. I've been in this area for about 30 years, working with my colleague David Smith and a few others. We are most noted for our work in computer gaming, which may sound odd that I'm up here talking about AI and machine learning today, but how many of you played a computer game in your life? So if you played computer games, especially the ones today, you know that AI is a very important part of that. If you're going to make convincing environments, convincing characters, you need to have a firm grasp of what I would call now the old AI. And that's one of the things we're going to do here today in our little session is differentiate, and this is very subjective from my point of view, between the old AI, really let's talk about 3 stages: old AI, what's happening now, and what's coming next. And we'll talk about that here today. But my colleagues and I here have formed a couple of game companies. Most noteworthy is Red Storm Entertainment with author Tom Clancy. You guys know Tom, right? When I speak to younger crowds today, I have to say, Tom Clancy did this game, or, he did this Patriot Games, Red Storm Entertainment, or Red Storm Hunt for Red October. We did another one with author Michael Crichton. You guys know Michael. I have to now describe who Michael is to most people and just say Jurassic Park. I can't say ER because they won't know that. And then Ozzy Osbourne, which everybody seems to know. Also Douglas Adams, a science fiction writer. Anybody know him? And of those 4, who's still alive? Just Ozzy, and that's it. And draw your own conclusions on that. But then we got into this once we got into the new century here, I created a company called 3D Solve to take all this great game technology and stuff we've been doing in the film industry for years and applying it to shortening the path to mastery using simulation learning for a whole wide variety of industries. But again, AI played an important component of that. And that ended up being acquired by Lockheed Martin. I'm just fast forwarding here a bit. I spent 6 years there. My colleagues and I all spent 6 years there working with VR, AR, and AI. And it's there that I discovered machine learning and got religion on it. So I'm going to tell that story and talk about that a little bit. But that's my perspective, and I hope to hear a little bit more about yours, those of you who I haven't already talked to today or at the beginning of this session. But that's where I'm coming from, all right? And then this is another perspective of mine. I was just talking about them with Sam over here. Do you guys recognize these two people? Anyone? Yes, sir. That's right. All right. I should have come with prizes like for that because, yeah, that's great. These two guys met on the advisory board of my last company. When I first met Joey, he was a DJ in Japan, in Tokyo. Didn't have a college degree. Now he's the director of the MIT Media Lab. Is this a great country or what? And then Reid Hoffman, who when I first met him was just out of the PayPal mafia, with Elon Musk and Peter Thiel, and had just formed this little company called LinkedIn. But both of them made an investment in my previous company. But a lot of the work that I do today with my teams is really informed. I think about like Reid sitting on this shoulder and Joey sitting on that shoulder. And they're advising me on things like David Weinberger's concept of, don't work and build complete, huge monolithic applications, but get rough consensus and running code. Harness network intelligence, all the things that we're now grasping in terms of like agile development and solving problems really quickly. That's why I started out with saying what I really want to focus on here today is something you can do in a very short amount of time that has a big impact in your organization. And you're going to leave here, I hope, with ideas around that. And the central thesis here is something that I've been thinking about for a long time. I wrote about it first in a TechCrunch article, I think in 15. And it's this very simple idea that I really think the critical problem, if you really distill all this stuff that we've been talking about today, and earlier you heard me ask questions about this ongoing battle over the last couple of centuries between capital and labor, right? That's the fundamental equation we're all trying to solve for. But I'm really thinking today about every organization, no matter what you're doing, whether you're a business, you're an institution of higher education, you're a government, even if you're an individual, you need to be thinking about what activities are we involved in and what of those activities should be done by machines and which should be done by humans. Very simple. Getting that balance right is going to be critical for being competitive. And I really think those who don't really focus on this not only will not be competitive soon, but will look and appear handicapped. All right. And it's happening fast because the answer to that question, and it's not just effort, right? It's not just human effort versus machine effort. It's also attention. As Herbert Simon said a while ago, one of the biggest resources of this century is human attention. So what should we be doing in an organization with human effort and human attention, and what should we turn over confidently to machines? Get that right, you'll prosper. Don't get it right, you're going to be in trouble. And I've got a bunch of articles I've written about superhuman education, superhuman healthcare. Been trying for the last year to do a book called Superhuman that talks about all this stuff with some of these real world applications. Hopefully I'll get that finished. So this is how I first got religion on this. And again, I like to boil everything down into these simple algorithms. But I was at Lockheed and we were working on, we got to play with a lot of different toys. Lockheed acquired my company and I stayed there I was going to stay there 2 years because they put these little, if you guys have ever been part of a company that gets acquired, they put these little buckets of gold every 6 months for 2 years to keep me there and my management team. I ended up staying 6 years because we were actually having quite a bit of fun. One of the things we discovered is at Lockheed, a big company, every time you do a patent disclosure, you get a check. So we turned that into our compensation program or sort of, incentive program because I had a lot of smart people working for me. So we had over 100 patent disclosures in, I think, 4.5 years. And most of them, like I said, AR, VR, and AI. So as a result of that, we had this group called Virtual World Labs that crossed all of the mission areas of Lockheed, so space, energy, all the different groups they had. And we got called by Microsoft to come out and just look at their project called Kinect, or at the time it was called Natal. You guys all recognize this? Some of you might have it in your living room. This was 2009, very seminal year for me. I was on the set of Avatar during that time. I spent a lot of time with Ray Kurzweil. I was just talking to some folks about. And but we were out there to help them and say, like, at Lockheed, we know a lot about sensors. Let's see if we can help you with the sensors that you're putting into this system. And that's, if you guys, anybody recognize these guys? So the guy on the left is Jaron Lanier. He's the guy who came up with the term virtual reality, invented the first data glove. I've known him for quite some time. We shared stages at virtual reality conferences back to the early 90s, seeing the, sort of spring and winter of VR that's now a spring again, apparently. And then on my right shoulder there is Alex Kipman. Alex is the inventor of that system, the Microsoft Kinect. And today's they're both working on HoloLens and some other projects at Microsoft. But again, pretty quickly we realized that, hey, the sensors you have are pretty good. There's this whole argument about time of flight versus structured light and all that stuff. But what attracted our attention is how they were trying to train the system. So all they were trying to do is train the system what a living room was, teach the system what a living room was. And that sounds very simple to us, but to a machine at that time, computational, I think even today, it's still a very difficult problem to say, that's a chair, that's a table, that's a sofa, this is a person. Can I tell the difference between each of you in different lighting conditions? And instead of doing it the old AI way, they were playing with this new stuff called machine learning, which is they had a supercomputer, and they were just feeding it every single example they could find from every living room in the world, from Europe, from Asia, from, what does a rural U.S. living room look like? What does a city living room look like? And just giving it massive sets of examples. And that's the magic right there. Instead of a human being sitting down and saying, let me tell this system what a living room is and program that logic in there, those logic gates. Instead, just give it a massive set of examples with some really good machine learning libraries, and it will figure that out. And the problem that they had is they'd already shipped Xboxes all over the planet, and they had about 100 megabytes of available storage. So that was a problem. So whatever they came up with, the brain that had to live on that system had to fit within 100 megs. And they did it using machine learning. So that's how I got gospel on that. I came back to Lockheed all very excited about it. And then I'll go through this really quickly because I think you've already talked about this in some of your earlier sessions. That's me with the founder of Atari, also the founder of a Chuck E. Cheese, Owen Bushnell, who needed a place to put his, Pac-Man and Pong games or whatever. But this early on, when Google got into machine learning, they could have taught a system to play Atari games by programming that logic in, but instead they just had it watch humans play, had it sort of discern or learn the rules from watching humans play, and very quickly could master those games. This, of course, is what a lot of us have been talking over the last day or so, is this caught, I think, a lot of us off guard. Because it's one thing for a machine to win at chess. Chess is a complex game. There's as many positions on a chessboard as there are stars in our galaxy. But it's still something that yields to the computational power that we have today, right? I mean, that first happened in 1997 was the first time a machine beat a human, Garry Kasparov, at chess. But this is now a game that has a lot of nuance to it, a lot of skills required that we believed were still in the sort of realm of human capabilities and far beyond any machines. And the AlphaGo system was able to beat the number one human player in the world pretty handily, much quicker or much sooner than any of us predicted. Caught a lot of us by surprise. And this, I like to show this for two reasons. And I'm just kind of creating some scaffolding here for some of the things we're going to be talking about. This also is pretty exciting, remains exciting. Anybody here working with GANs? Yeah, these generative adversarial networks. So this was, AlphaGo had already beat the number one human player in the world, and now they created a system which played a new system which played the AlphaGo system. So starting without knowing anything about the game, just started playing lots and lots of iterations of this game, not even knowing what the rules were, was able to master it in this short amount of time. And this curve I like to show because that's kind of the machine learning curve we have with anything. Anytime we try to train a system about anything, if I'm trying to train a system about contracts or how to improve purchasing in a medical environment or improve, banking systems, I always have this sort of cold start problem, right? Like, how do I get it up that curve? And I'd rather that not take months and months, but can I have enough good examples for it to work on so it can crunch through them in a matter of days and sort of achieve that better than human mastery faster. That's what we're all aiming for. That's kind of the holy grail right there. All right, so the first project I worked on when I was still at Lockheed Martin was a pretty simple one. Arnie Duncan and Jim Shelton from the Department of Education came to Lockheed Martin, of all places, and said, we understand you guys are playing with machine learning. We have this problem, or this opportunity, I'd say, in that we at the government have a lot of really interesting information. Think about all the stuff archived at the Smithsonian, for example, right? We'd like to make that available to educators and students all across America. So we've got a team of an army of human beings going through all those archives, trying to like take a picture of something or scan in a document and then type in, some kind of keywords to make these things transparent to inquiry, really. And I call that, if you recognize that scene, that's kind of the last scene from Raiders of the Lost Ark, where you've got this incredibly potent, powerful artifact that could either save or destroy the planet. And a clerk has said, Ark thingy, put the tag on it. I've tagged it, right? It should be searchable now. And then puts it into this big database. And that's the nature of a lot of the data that's out there today. A lot of the big data that people think they have is unknowable, unfindable, and not transparent to inquiry. So how do you fix that problem? Well, one way is to have human beings open up each thing and try to tag it better. And that's what they were trying to do with this learning registry problem. What we did is built a machine learning system, very rudimentary, again, who just, do you guys see Watson play Jeopardy? So you know how it sort of comes up with an answer and it might rank them by confidence level. So we had a system that was similar to that. It would look at something and say, I think this is ancient Cluniac drinking vessel from 100 AD. And if its confidence level was above a certain threshold, like 65, 70%, it wouldn't bother a human being. It would just go ahead and tag it, right? Now, if it was below that level and said, I'm only 40% confident I know what this thing is, then it submits it to human experts. The human experts then use their special human capability to say, no, that's actually an ancient Roman vessel, drinking vessel from 50 BC. And of course, the great thing about machines is once they get that pairing in their database, they never forget that. That's simply all it is, right? The magic powers of machine learning are to go through a lot of stuff very quickly, try to come up with some discernment or pattern matching around it and say, I have an example in my database of something similar. Here's my confidence level of what it is. And if I get a better example, then I can improve that judgment. And of course, I'd never forget it. Very simple. But with those very simple ideas, we can do some really powerful things. I just saw I don't know what's happening here, but Natal, the Microsoft Kinect system was discontinued this 6 months ago. And they just turned the learning registry off because nobody was using it, which is a little upsetting to me. Here's another cool thing we did. We were in, right after I formed Tanjo with my colleagues in 2014, we were talking to some lawyers who I said, hey, you guys have a lot of data, right? You have a lot of information. We can help you. And they said, yeah, if you could build a system that could understand the law and help me with cases, boy, you'd be worth $100 million instantly. And we're like, oh, really? Let's go find a data set. Does anybody have a data set? That's usually how all of our conversations, our Monday morning meetings start with, where's the training data, right? But we did find a data set of every single legal opinion ever rendered in United States history since 1797. That's what machine learning likes, right? 4 million plus documents. And so we fed it into our machine learning brain and let it crunch on that. And not even with, we put like a like a $2,500 NVIDIA GPU on a system sitting in our office. And it took it about 7 days to read through all that text, map it all, and create an understanding, a discernment database of that system. Are any lawyers in here? So as we started bringing this to market, we ran into a little issue, which is Most law firms I'm finding have still that Raiders of the Lost Ark problem in that, and most of it's driven by policy. They've got lots and lots of data about how their firm has dealt with cases over the last couple of decades, but it's all like only that person who worked on that or people with specific permissions can have access to that document for client privilege reasons. Yes. Well, that's what we ran into. We thought, hey, we did it. All right, where's the $100 million, right? And we started going to law firms, and we did get a few people to use it, and they started saying, first of all, when I'm working on a case, it's bringing me like way too much information, so we need to winnow that down. So we created a system to help them sort of winnow that down. But also what they really wanted was something to say, all right, I'm going to this judge in this case or this venue. I need cases that judge is already familiar with. Like you haven't gotten me the last mile. You've given me big data, right? And one of the things I like to talk about is, there's big data, which everybody has today, but it's a big leap from big data to information, and then an even bigger leap from information to intelligence, which is something that's given me what I need when I need it in a meaningful way so I can act on it. Just giving me big data doesn't do anything except confuse me, right? It's like there's too many options. So that hasn't been a very ripe market for us. And I think guys like Westlaw and people like that are doing a great job. So we kind of skip past this. We've had to pivot a couple of times, and I'm fast forwarding through some of these pivots just because I want to get to the juicier stuff. Here's a good one though. And you know what? One of the things that will happen as you become aware of the things we're talking about here today is you start, it's kind of like if you go to a new city for the first time and you walk through the city just by yourself, you experience it a certain way, right? But if you walk through that same city with a camera, now you're looking at it different, right? Because now you're looking at like, how do I take photos here? That's just one example. But what you'll start seeing as you understand these machine learning powers is you'll start recognizing all the opportunities to employ it within your organization. So this is something we saw. I was talking to some CPAs. I was speaking at a conference actually in Atlanta, Georgia called Audit U, and they were all sort of running around. They're like, hey, there's these new rules coming out December 1st, 2017 around revenue recognition and lease recognition coming out from FASB, right? And are like having conferences about it. How are we going to prepare ourselves? How are we going to prepare our clients for this big change that's happening? And I looked at that and I said, wow, machine learning, great machine learning problem, right? Because there's the old AI of like, what are the new rules, which is kind of old AI, I can kind of program those. And then all I need is a big training set of give me every sales contract you can give me, and I will train a system that can do that instantly with the new rules, can provide that judgment, right? You don't have to guess about you don't have to train people to do it. The machine will do it, right? And it didn't, same thing. It was about a 2-month project. But the problem is, first day, we sat down at the table with these folks and said, all right, where's the training data? They slid over very proudly about a thumb drive. We put it in, and there were about 200 contracts on there. So perhaps we weren't clear, right? We don't need, what's the minimum, Sam? At least 10,000 somethings. Yeah, otherwise it's like trying to teach my kid, like what is, anything. Like you have to give them enough examples. And we really like to have millions. So we actually had to go out and find on our own. And once again, we just decided 4 million is a good number. So we found 4 million sales agreements, everything from a scanned in, purchase order that's been handwritten by someone to buy something to a 100-page contract that has milestones and warranties and disclaimers and all that sort of legal language phrased in all the various different ways that lawyers phrase them. I'm trying not to look at her while I say this, but they phrase them all. There's no standard way to say a lot of this stuff. There should be. And maybe blockchain will fix this. Am I the first person to say blockchain today? Aren't balloons supposed to come down or something? I don't know. So anyway, so we built that system very quickly. And again, it's a 10x roughly ROI thing. They need 10% of the people they thought they were going to need to do the same job. And they're never going to need those people again. And one of the people in that conference, or a later conference when I was talking about this, a younger person said, hey, if I can have a machine go through all those documents, it raises a lot of problems. Number one, the old way of auditing, are there any people in accounting here or auditing? The old way, if you had to audit Enron, let's say, whenever they were doing their thing, 2000s or whatever it was, you would come in with a team of people and you would sample their transactions, right? Why? because humans can't read all that stuff. There's way too many things for a human, and then you rely on the statements from management to make your judgment, right? Well, when you start deploying stuff like this, what's the problem? Now you can do all of it. There's no excuse not to do all of it, because the machine can read every single transaction, can apply some kind of judgment. At the very least, it can bin sort it, right, and say, here's a whole bunch of things that look standard and no problem with that. These are a little dicey. I'm going to put these in the yellow category. And all these offshore transactions look a little weird and they're on fire, and a human being needs to look at these immediately, right? That's helpful just on its own. But we can do that now. And the next step is, if I can do that with auditing, why would I even audit anymore? Why would I wait until the end of the year to look backwards? Why don't I do that in real time all the time? And why doesn't every company have their own system? So you see where I'm going with this, how this sort of transforms everything once you realize what this very simple set of applications can do. But this is the kind of thing that we're doing. So I'll tell you another quick story. JP Morgan, big company. Any JP Morgan people here? All right, let's talk about them. So, the first time you ever meet with a JP Morgan person, they spend a lot of time talking about how big they are. Here's how many assets we have under management. We're huge, and take me very seriously, right? Whatever, that's how it starts. But one of the things we found, we ended up doing a workshop with them very similar to this, about a one-day workshop on, here's all the stuff you can do right now. Let's look at all the activities that you're doing and find something juicy like this we can apply machine learning to. And we found one pretty quickly. In fact, we found a lot of stuff. First thing is, they were spending 340,000 hours a year just reviewing loan agreements across JP Morgan. And I like to say 340,000 hours of New York lawyer time. So what is that? Anyone? $800 an hour? Maybe, Jeff? I don't know. So it's a $300 million problem, right? And we said, you can demolish that with machine learning. And sure enough, they ended up not even using us. That's cool. Like, it's not really cool. I wish they'd used us, but they had their own internal team. They spent way more money than it would have cost us to do it. But in the end, it's less than 30,000 hours they spent. I don't know what those poor New York lawyers are doing now. But, they did this thing one time that took about 6 months to do. And it's a return on investment of $240 million, best I heard. And the cool thing about it is, it's not just a one-time return. It's an annuity. This cost that they've just assumed we always have this cost. At JP Morgan, just put it in the budget. We have 340,000 hours, $300 million a year of New York lawyer time to review these loan agreements. They're never going to have that expense anymore. So what happens to their competitors who still have that expense? Are they going to be competitive anymore? And guess what JP Morgan's doing right now? They're looking at absolutely everything they're doing, trying to figure out what can we apply machine learning to, because, wow, what a competitive advantage. We won't have costs that our competitors will have. We can take more profit, because I doubt they're reducing their fees. But anyway, that's the kind of cool stuff we can do. Here's another cool idea I want to fix in your brain. This is the thing I really like about machine learning, because it structurally changes how you look at problems. So we call it the new scientific method. What's the old scientific method? Human being admires a problem. Maybe a bunch of human beings admire a problem, and they come up with an hypothesis. Then they design some experiments and go test those experiments. Well, with machine learning, you have another tool, right? It's another button on the calculator, as my CTO likes to say. Because now what we do is we just dump all the data in the top and say, machine learning system. We don't have to talk to it really, but sometimes we do. Don't judge us for that. And we say, find me every hypothesis that might be meaningful, and rank them in rank order by how interesting you think they might be to me. And that's what it does. And when we do this exercise with clients, I can't tell you how many meetings we've been in when someone says, here's our client database, here's who our clients are, here's what they care about, and here's how we sell to them. We're like, great. So that's what you guys, with your human experience and your human perspective, think your customers are and where the future's going, right? Let's see what the machine thinks. And the machine finds something different practically every time. And I could give you some examples. I'll give you a real quick one. So we had a software company that was selling tax prep software, has been selling it to people for 30 years, 25 or something like that. They said, and again, you meet with these people, they're like, I've been doing this for a long time. I know my customer. You're not going to tell me anything I don't know. We dump it into the system, and we come back pretty quickly and say, you ought to consider a affiliate marketing program for community colleges. So like, why on earth would we do that? Well, the largest growth factor in your customer base right now are community college students. And they start going through their tables of data. Where's that? Where does it say that? Well, it doesn't say that explicitly anywhere, right? There's a category somewhere that says student, and then there's some other stuff like has 2 kids, 35 years old, lives in a rural area. And the machine, by mapping that to some other databases we have about census data, human behavior data, consumer behavior data, comes out and says 90% likelihood or confidence level, these are community college people. In short, they end up with this new insight, end up creating a program around community colleges, very successful, changing their business. I mean, again, a very simple thing that was done in just a couple of hours. So just keep that in mind as you start thinking about digital transformation and problems that you're admiring. And again, this is completely subjective, how I think about AI, and feel free to challenge me on it. I just choose 2009 because that was a earth-shattering change year for me. But for some of you, maybe like, again, Sam and Jeff at SRI and others, maybe you were exposed to it earlier than I was. But I say the old AI was, you don't ask a machine to do anything until a human understands it completely. Then you sit down and you write that rigid, fragile logic, that brittle logic into a system, right? And that's why autonomous vehicles failed early on, right? Because we tried to say, how would a machine drive a car? Well, how do I drive a car? It turns out no one can really describe that, convincingly. How does a human being drive a car? It's not about calculating all the information around you, right? It's mostly about ignoring everything around you and driving. We can't really explain it. Like, how do you catch a ball? How do you throw a ball? Like, it's hard to break that down computationally. So with machine learning, though, by saying that, machines, by the way, drive differently. They have different inputs. They have, like the one out there, GPS, LiDAR, optical sensors, different inputs and outputs. And they give them all those examples. That was the big breakthrough between 2004 when all those, if you saw the early DARPA challenge, when those vehicles went, 100 yards across the desert and ran into a rock or lost their signal or whatever, just failed, to like 2 years later, able to all of a sudden navigate. That was early machine learning. And that was the big breakthrough. So in this phase, the phase that we're in now with machine learning, where it's about examples, training sets, and algorithms and good machine learning systems, it's all about like, how do we find enough data? I can't find enough data scientists. You guys having that problem, right? And it's not just statisticians. You want to get people who fundamentally understand how machine learning works, how to prep data that then goes into the system so they can train efficiently. Can't find enough. This next phase where we're going right now, I'm actually a lot more excited about. It's getting weird, very cool, and that's what I want to talk about next, with your permission. Is what I'm doing right now is I'm looking for people at the intersection of the cognitive sciences and psychiatry and consumer behavior, economics, where we just gave a couple of Nobel Prizes recently, right? Those are the people I'm reaching out to. So here's who I found. I just got an email this morning from Dr. Carson. That's him here. He's the head of the economics department at UCal San Diego. He's the guy the U.S. government calls when you have things like the BP oil spill to say, like, what are the real effects of this going to be to the economy? He's the one who calculates all that stuff, or climate change or anything else. He sent me one today about the upcoming election. I'd be willing to share it with some of you. He's going to make it public, but he's got actual algorithms he's figured out around human behavior, choice modeling, and how we can figure out what's actually going to happen. Pretty cool. But the reason I reached out to him and Dr. Jordan Louvier, who's the foremost authority in the world on choice modeling, how do humans make choices, he'll actually tell you, most cited academic on the planet in this field, lives in Seattle now. When I first met him, he was in Australia. And that's actually one of your IBM colleagues there, Sam, working with me, Kevin Clark, who is the brand manager for the IBM ThinkPad. But what we've done is we've said, here's the old way of looking at how you actually try to discern human behavior and understand humans better. And what can we do with machine learning to attack that problem? And now we're, October 1st, Gartner just recognized us on their cool vendor list for the few breakthroughs we've achieved there. This is the other book that Jordan and Richard said, read this first. Has anybody read this? Really interesting read, not that well written, but there's a fundamental truth in there that Netflix knows. I think IBM knows this. A lot of other people, Amazon knows this. That is, if you want to understand human behavior, you don't ask people, like, what kind of shows? If you guys have two choices tonight, you can watch Lawrence of Arabia or Hot Tub Time Machine. What are you going to watch? Start going around the room, right? Oh, Lawrence of Arabia, fine cinematography, beautiful, fine acting. What do they do when they go home and nobody's watching? They watch Hot Tub Time Machine, right? And that's what Netflix learned. Like, don't do questionnaires, don't do surveys. Just see, what do people do with their attention and their money? That's who people really are. And this whole book said, hey, exit polls and surveys did not predict Donald Trump, didn't predict Brexit, right? You know what did? Google search data, right? That predicted it. You could see who people really were. If you want to know who people are, you look at Google search data. Now, I couldn't get the Google search data for our stuff, so I ended up cutting a deal with Nielsen because that's kind of the next best thing. Nielsen knows what people spend money on, right? And they also have watch data. And I want both. I want attention and money. That's who people really are. And so that's information we're getting in a raw form of, I get data sets like 65,000 households, everything they bought in the last year. And it's amazing how revealing that is. The machine learning system will sift that into here's 100 different kinds of people, right, who buy things and what you know about them. And you map that over to census data, consumer behavior data that we can get from the government, and you have a very rich data set. And don't start getting all GDPR freaked out on me yet, because I'm going to talk about how we're fixing that. So we went and talked to the market research people. And one of the things I found is there's a lot of money being spent, like $3 billion a year, just in the U.S. by Procter & Gamble and all these other consumer companies trying to understand human behavior, right? And what do? They do focus groups, and they do surveys, and then they build these segmentation models. And they'll say, I was joking with someone earlier about this, where they come back and say, well, at Procter & Gamble, you have basically 8 kinds of people. And here's who they are. Here's iPhone mom, here's Joey Gearhead. And it's done in one segmentation model study. And then, it was 18 months ago, and this is truth. And everything we design around our products and our marketing and everything comes from this study done 18 months ago. And I was like, well, I just came from Lockheed Martin, and that's crazy. Like, we would never do that. Like, when we were building big, huge constructive simulations of entire countries to make better decisions, we had sims of the entire planet, right? But if I was modeling Afghanistan, I wouldn't say, well, you got basically 2 kinds of people. You got your Sunnis, you got your Shias, right? That is far too simplistic, right? People are a lot more complex than that. So we would build these big constructive sims that have 6 million agent-based models in them, and we would run these massive sets of sims on it and then come up with the Monte Carlo distribution of, potential outcomes and say, this is what's most likely to happen if you go build that school there, or if you improve that road, or you teach girls to read in Afghanistan, you can expect these responses from all these different kinds of people. And that turns out to be really useful. And that is a discipline in the Department of Defense that now we've been doing for many, many decades. And it's all about the data. There's a whole team of people spend all their time just trying to validate information, right? Like, how do I validate these models that go in to drive these simulations? That's what the whole exercise is about. We got to figure out how to do that for companies, because right now what you're doing, I think, is far too simplistic. But I will say, my first inclination was to say, well, why don't you have 116 million segmentation models, like at least one for every household? They're like, well, that's crazy. How would you deal with that much data? And I was like, we do that all the time. We can do that, right? But as I started putting that into practice, I realized, I'm going to not name any company names here, but working with a very large chicken company. And I said, we're going to do 116 million. I've got all this Nielsen data and all this. And I'm like, great, let's see what it looks like, right? And one of the things we found pretty quickly is there are not 116 million meaningfully different ways to buy chicken. If you're interested, it turns out to be about 40, right? But it's not 10, it's not 5. And that's the exercise that we ended up creating for them. But I think pretty soon you're going to have, every company should have their own little synthetic population of people, of their customers on which they can test ideas, and stop calling people at home and doing surveys and stuff, because they're all flawed. People lie. even when they're not lying, they're biased, it's not good data. Whereas the data is the data, right? It's all about getting good data. So here's how we build models of people, and I'm going to jump forward through this, but again, just starting with really low-level stuff like census data and whatever I can build. And I think RTI has some really good sort of public health models that we can look at. Then if I can get data about choices they've made or things they've written or whatever, I can now build an interest graph of a person. And then if I know what they did, and then personality and sentiment comes from things like writing. We almost made a dating product a couple of years ago with my company. I'm glad we didn't. But we found a great training data set of like 3 million OkCupid profiles. And they're very rich, and they reveal a lot about people. And we could, well, so you have to solve for that. Like, I don't think my Facebook interest graph, if you guys have ever looked at your Facebook interest graph, it is not accurate. Like, I don't think it's true of me at all, because, and they're constantly trying to improve it. But, the reason I friended that person in my high school or liked that cat picture, they go like, oh, Richard really likes cats, and he really likes these people from his high school. No, I'm just being nice in some cases, right? And the persona I have inside of Facebook is different from the one I have in Twitter or LinkedIn, right? And I'm like user number 800 on LinkedIn or 1100 or something, I forgot. But my behavior is different, so I'm a different person. But anyway, and I never like to say we get 100% because humans are, mercurial and change their minds and whatever. But if you get up this scale, you get some really good predictive capabilities that far exceed just doing surveys and focus groups, right? And I'll just give you some examples I did for fun. First one I did about 15 months ago said, okay, where's my training data? Well, I can get everything Victor Hugo ever wrote and everything written about him, put that into the system, and have it build a nice like sentiment graph and interest graph of him. Released him on the net the next day, and every day now I can go visit Victor Hugo and see what he thinks about current events. And he's actually reading on the net. And he's not reading like 2 or 3 things. He'll read 100,000 articles, right? And he'll rank them and score everything and give me his opinion. Like, what does he like, not like, right? It's kind of interesting, right? Did that for people like George Washington, Martin Luther King, and I don't know if you can see some of these things, but again, every day, what do they think about? What do they care about? And that's interesting if I just have enough data, right? But then it gets a lot more interesting that this next thing we're doing in marketing is what if I can then write to them? I don't think this is automating someone. Oh, it is. So now I can actually write to them and improve this communication with my customers, right? Without bothering them in the real world, I can write to them and they'll tell me by person or persona type how interested they are. So I know if I'm going to be targeting iPhone mom, then I would use a certain kind of language with her, and I could watch as I put that text in there. You'll see that change in near real time in terms of their interest. So there's a lot of things you can do with this. Number one is just make sure that instead of that segmentation model study that sits in a folder somewhere that people look at occasionally when they design market research or design marketing applications or marketing programs, is that they can actually make sure that they're communicating in a consistent way with who they think that customer is, at a very minimum, right? But second, you can end up having, if I get enough data, if I can climb up that 80% graph enough, I can get to the point where I can actually ask them questions, right? So I can take data about, I'll give you a very real example, pharmaceutical company, however you feel, anybody from pharmaceutical here? All right, so pharmaceutical company, they care deeply about how do I get doctors to prescribe my drug. They spend a lot of money, survey stuff. They'll send a survey to a doctor, give them $500 to fill it out. Now, what does that busy doctor do very often? Hey, Junior, come over here, fill that out. I want to get $500. How accurate is that data? Not very good, but it costs a lot of money, right? Well, what if I can now that I have the HR data on that doctor, I can get from IQVIA and people like that, I can get that data that says when that, and again, protecting the privacy of the patients, I can say when that doctor encounters this kind of patient with these kind of symptoms, they tend to prescribe this, right? And I have that history of data. Now I can build models of all the oncologists in the country or all the cardiologists or whatever you want. And I can use that data. Instead of asking people questions and doing surveys, I can build simulated worlds where I test my ideas instead of doing these focus groups and surveys. Yes, sir. Mm-hmm.
Or just running them out in the room.
Yeah. So empirical data. So that's what's building right now and getting exciting now. So we haven't published anything yet, but we can't get the deals that we're getting now without walking into Campbell's or, again, I wouldn't say any, but companies like that without some kind of like empirical evidence. Like, here's what we did. So again, I'll give you a chicken example without naming a company. Do your surveys and focus groups on chicken. Okay, here's some choices for you guys at this table. Here's organic chicken. It's twice the cost. You can have this other kind of chicken. It's half the cost, but it says antibiotic free on it, right? So there's no antibiotics used ever. It's cage free, free range, whatever you want. They test all those different ideas. Now, clearly, most people would say like, well, the organic chicken is healthier for my family. How do they answer? If I take that survey data, I would say, well, when we go into the stores in North Carolina, 70% of our shelf space should be filled. I'm using just made up numbers right now, but a large percentage should be organic chicken. But when I take the Nielsen data and I look at it, it's the other way around. They say one thing. When they go in, they go like, oh, organic chicken. I'm going to go, well, look at that, though. It's $8 a pound. This is $3.99. That's good enough for this week. I didn't have a great week this week. Trying to trim on the budget, right? Family won't know, and they do that. So that data is more important than the focus groups and surveys. So we have those studies that have done that. Now, one of the 1600x examples that I was alluding to earlier was at the chicken company. So we're seeing just like use data. I mean, we're not trying to remove human intuition at all, but man, the data only can represent the data. It can't lie. So the big question is, do you have enough good data? And the problem we run into usually is like they don't, right? Unless you can get into IQVIA and get into Nielsen and get into, ideally, the holy grail is like all that Google search data, which they won't give me. But if I had that, I could build a really, really deep model of human behavior by household and tell you how they're going to vote, how they're going to make decisions. And again, you can't, and we don't do this in the DoD either. We don't say like, well, we did that study 2 years ago. There it is. Here's who these people are. It's got to be real time all the time, as often as you can do it, feeding into these systems. Yes, sir. No, it's nothing that complex. It's so simple. It's taking a bunch of data, like purchase data, feeding in, looking for correlated patterns, grouping those people into patterns, and then a human comes in and names them like, well, here's like, I don't know, any of you guys from up north, like the New England area? What's this brown? There's like a brown bread that's in a can. Like there's people that buy brown bread in a can, and they also buy these other weird things. I'm like, who are these people? But it reveals that. That's really all it does. And then from that, though, you can match that up, marry that up to other information. And God, if I can also map that to social media stuff, then I can get my sentiment graph and stuff like that. But typically, I don't have the sentiment information because I just don't have it. Unless I'm dealing with and this is where it gets interesting. If I take all that stuff from Nielsen and Census and whatever, then I go talk to the chicken company and they said, here's a bunch of information we have about how people buy stuff, either direct or, we've worked with some of these mail order food companies where they have a lot of rich data because they have that one-to-one interaction with the customer, where it gets really interesting really fast. I have good data. Usually I'm working with partial data. So if I have the lower level data, what I'm doing is I can monitor them, see how they're reacting to current events, and try to use that in how I do my marketing, and I can practice my messaging. I can't ask them questions unless I have the deeper data sets. And we only have a handful of those examples so far because it requires a lot of trust from the company to give us that data. We got to promise never to use it with any other chicken company or with, that kind of thing. But it's definitely there. And again, this isn't stuff we're making up. This is a practice in the DoD that's been going on for decades, and it's a known science. It's just not being done in other areas. So this is just sort of a personal thing. You guys know Ray Kurzweil? So Ray's talked a lot about collect. He's got a whole room full of data about his dad, and one day he's going to resurrect him. Well, my dad died last year, and naturally, of course, I had to do this, right? And the problem was he wasn't on LinkedIn. He wasn't on Facebook. Very rich life, 85 years old. He was twice decorated in Vietnam, fighter pilot, had his master's in music, competed in long distance shooting, set 2 national records at 1,000 yards. Was in, like I said, Boy Scouts, model railroads, all this stuff. So I had to take all of his military records, personal documents, put that in. Then I hand built the rest of it because I have firsthand experience of my dad. And now I can go visit my dad any day and see like what he thinks. And there's an Ad Age article where they sort of dig into this experience that I had. And I have to say, like, especially early after he died, it was this weird, however you guys feel, you're getting a little queasy, I can tell, but it was oddly comforting and reassuring to be able to, like, I'm seeing how my dad is experiencing the world still. And I'm almost find myself like wanting to argue with him, this shadow version of him, because we never agreed on a lot of things. But because I saw him react to certain things, I'm like, no, you're wrong in that. Like, oh, well, that's right. I can't have that argument yet. Because one of the games we built for Douglas Adams was called Starship Titanic. Anybody? No. But this was 1997. We actually built a natural language processing system with chatbots in it, so you could actually talk to the characters. That was 1997. I can only imagine what we can do with that now. Now, we haven't done it yet, but that's the next step, is I want to be able to talk to these characters. But again, think of it from how many of you are RTI people? So you guys are interested in public health around the world, like what's going on. Like, what if I could have a big database of everybody in sub-Saharan Africa that was modeled off of their data, assuming I could get it, and then you could actually ask questions, say, what could I do to get them to take these malaria prevention measures or these counter STD measures or whatever it is, and how do I communicate with each group? You'd be able to do that with a system like this. So it's interesting and not terribly hard to build. But again, this is what we're after, this 10x kind of ROI. Yes? All right. Mm-hmm. Well, first of all, those early ones were just sort of like, we called it the empathy engine, like see the current events through the eyes of it. And so we put it into some community colleges. We had some people some teachers trying to build some curricula around it. So that was just the first step. And we really didn't have any ambitions beyond that. And we were just playing around with it when we showed it to a consumer goods company. And they're like, hold the phone, could you do this? And we're like, oh yeah, is that interesting? And then they told us what they were doing with segmentation studies. And that's when we went like, are you kidding me? That's what you do? That's what you spend $3 billion on every year? God, we can help you. So initially, like if I can get that enough writings by that person, or in the case of like Victor Hugo or Franklin Delano Roosevelt, you would also get a lot of critique of him, probably from people writing about him, right? So from that, I can build a pretty decent model, but it is just the model. Is it him? No, it's the data representation of him, right? But I can use that to try to understand him better. Can I ask him a question like, would you prefer that red piece of luggage or this black piece of luggage? He wouldn't have probably any preference for that unless there was something in his data that we captured too, that where he'd made that pairing choice before, and it was substantially similar. But otherwise, all I can see is we play around with some Likert scale stuff, like how likely would you be to approve of this or not? And they would be like strongly agree, strongly disagree. And then you could sort of dig into it and see like, why did he feel that way? But it is kind of a art and a science kind of blended together. Is it tremendously accurate? Well, the great thing about dead people is there's no way to know. And I don't know if he would actually like that or not. But it is it's extraordinarily interesting. But if I do have that record of what, like everything someone's bought on Amazon, I can use that to be a pretty good predictor of new products that maybe don't exist yet. If I can have the machine map it back and say, well, this new thing that doesn't exist has these attributes that are similar to this other thing that he's bought before. And of course, Amazon is doing that. But those are the sort of questions you can answer. Yes. I haven't gone that far with him yet. I still don't know if I'm ready for that, but I mean, yeah, I could. Just like, well, no, but we did do that with Van Gogh for a bit, just playing with a chatbot thing. But was it satisfying? No, because I didn't really have enough data yet. But the Likert scale stuff was interesting. And when I said I went down and spoke in Buenos Aires and Medellin, boy, I got mobbed about this down there. And there is something, about Latin American culture around like veneration of your ancestors, like this idea. And people keep telling me to make this into a product. It's just not what I'm really. But does that opportunity exist? Yeah, like every major life decision I'm going to make, could I say, well, let me ask my dad, my uncle, my grandmother, Leonardo da Vinci, Martin Luther King, and have them render an opinion on this decision I'm trying to make. Well, that's what I mean by it's mostly an art. So how accurate it is, I would say even this model of my dad is my model of my dad. Is it really, would he agree with who I think he is? Maybe not. But it's like I said, it's useful to me. So anyway, so the last point I want to make, looking at everything we talked about and where you might apply it, is one of the things I really believe strongly in is this sort of delineation between research, development, and integration when it comes to technologies like this. There's people out there doing great R&D in machine learning and AI. I'm not one of them. I don't want my team spending any time trying to discover new things. I want to find stuff that already works, that's been developed at Google, DARPA, IBM. I don't know, like IBM has broken a lot of ground for us all, right? But I want to take those bits that work, not the ones that we don't know if they work yet, just the things that work flawlessly when given enough data, and I want to integrate those. So there's uppercase R, there's lowercase r in my world, there's uppercase D, there's lowercase d, and then there's integration. You want to do lowercase d and integration. Things you can do in a matter of months. They cost not millions or hundreds of millions of dollars with uncertain outcomes, but with known outcomes and useful tools you can play with that are certain of success. And the point is that the thing that keeps me up at night when I go and meet with companies is like I see it everywhere. And nowhere do I see it more than within government. And if you're tracking government RFPs at all, this is the year of machine learning. I know this because our phone is ringing off the hook. Because what happens, do any of you do government contracting? So when RFPs come out from, I don't care if it's DARPA, IARPA, or maybe they don't care as much, but if it's any of the other more routine agencies, they're like, you must have demonstrated a machine learning capability and show us your past performance. And there's companies that don't have past performance that want to play. Guess who they're calling? Well, they're calling IBM, they're calling Google, they're calling us to team with them. But I don't want to go and do service work on these projects. I want to go and say, here's a ready working system you can implement inside your company right now, inside your firewall, under your control, that you can build these applications today. And here's our past performance with all these case studies that you can use. And that's happening very, very fast. So it's an exciting world. There's low-hanging fruit everywhere. This isn't a pipe dream. It's not R&D or alchemy. All right, all right. Any more questions?